Welcome, Shrikant. Is this audible? Is this audible? We are just waiting for 2 more minutes. Then we will start the section. Is this audible? Reply in chat. Is this audible? Reply. Okay, Shrikant, thanks. We are just starting. We are just waiting for 2 more minutes. Then we will start today's section. We are just waiting for 2 more minutes. Then we will start today's section. We are just waiting for 2 more minutes. Then we will start today's section. So here I am sharing my screen. So today we are going to see about the hydraulic transmission. So what is hydraulic transmission? In case of hydraulic transmission, we are transmitting power from engine to uh, load, or from engine to the wheels. We are transferring power from engine to wheels using the oil. Which is, so we are calling it as hydraulic transmission. So what is we are doing here? We are transmitting power from engine to wheels using hydraulic oil. So we are naming it as hydraulic transmission. Okay. The diagram for hydraulic transmission you can see on your screen. It is having IC engine, and this IC engine is connected with the pump. The pump is connected to the motor, and these motors are coupled with the wheels, so that the power generated at engine is used as is transmitted to the wheels, and we are using it. So the power transmission is taking place here using the oil. So we are naming it as hydraulic transmission. Just listen to me. In case of normal vehicle, rotary motion produced by the engine is transmitted to the wheels through a mechanical power transmission system consisting of belt, clutches, gearbox, axle, shaft, and various mechanical components like pin, some couplings there. But here, in case of hydraulic system, we are going to use only engine, pump, motor, and these motors are remain coupled with the wheel. So number of components in hydraulic transmission system are less as compared to the mechanical power transmission system. And in mechanical power transmission system, there is a use of gears, and use of gears is completely eliminated here in hydraulic transmission system. The power transmission system also perform the task of modification of the speed of vehicle by engaging and disengaging of gear at different level. The changing of gears either manually or automatically create disturbance in the power transmission of the vehicle. You know, while driving any two-wheeler or four-wheeler, you need to change the gears if there is a mechanical power transmission system, but this concept is completely eliminated under hydraulic transmission system where gear removal, gear engagement disengagement is not required here in hydraulic power transmission. The problem is solved by continuous variable transmission CVT, which is also called as gearless transmission. So the gearless transmission is performed here by using continuous variable transmission. The hydrostatic transmission is one of the modern types of CVT system and it is used in most of the modern vehicles. So the modern vehicles which are automated one without gear or you can call it is an automated vehicle, they are mostly using hydraulic transmission system as CVT means continuous variable transmission. Hydrostatic transmission system finds application in most of heavy equipment such as excavators, forklifts, agriculture tractors, riding movers, and even tanks. In case, just listen to me very carefully. Hydraulic transmission system is used as shown in figure. It has a hydraulic variable displacement pump and variable speed motors. They are typically swash plate axial piston pump type. The pump shaft is connected to the engine shaft. Thus, the engine drives the pump and the pump pumps the hydraulic oil under pressure to the motor through pipes. The motors are coupled to the wheel shaft and hence the wheels rotate. Here what is happening? We are using the IC engine. This IC engine is connected to the pump. Pump pumps the hydraulic fluid or oil which runs the motor and these motors are connected with the wheels. These two motors are used to drive using the pump here. So how they are? We are connecting here. Engine is connected to the pump. Pump is connected to the motor, and these motors are coupled with the wheel. So power is get transmitted from IC engine to wheels using the hydraulic oil. And again here we are using the swash plate. So uh, you you want to take vehicle in forward and backward direction. So how this is achieved here? So here when there is a provision of hand lever. When the hand lever is in neutral position, the swash plate is at okay. Just wait a minute, please. Just wait a minute. Okay, so here we are at swash plate. When the hand lever is in neutral position, the swash plate is at right angle to the cylinder axis. Snow fluid is pumped to the motor and the wheel do not rotate. And when we want to take this vehicle in forward direction, then the hand lever is moved forward. The swash plate is tilted in forward direction. Pump pumps the oil in forward direction and motor and wheel rotates in forward direction. The discharge of pump and the speed of vehicle are proportional to the angle of swash plate. And when we want to move the vehicle in backward direction, at that time we push the lever in the backward direction from its neutral position and then the swash plate tilt in backward direction. This causes the pump to deliver oil in reverse direction and hence the motor and wheel rotate in reverse direction. Here we are supplying power to the rear wheels only, not front wheels. Front wheels are automatically moving here as the rear wheel is moving. Here you can see how this pump is connected with the motor. And you know that how this motor can be connected to the shaft, to the wheels. We are achieving this by coupling here. So in this video you can see that how this pump is connected with the motor using the hydraulic oil, and how they are going to transfer the power from pump to the motor. So you can see here as the shaft of this pump is connected to the IC engine. IC engine rotates the pump. Then this pump start to compress the oil, and this compressed oil is sent to the motor. So according to the speed of pump, we can rotate the motor. And this clockwise and anti-clockwise rotation of this pump is achieved by with the help of lever. When you push the lever in forward direction, then our vehicle goes in forward direction, and when we push back the lever in backward direction, then vehicle moves in backward direction. These are some internal assembly of this engine, motor, and hydraulic power transmission here. So it is okay. Now we are going to see advantages, disadvantages of this hydraulic transmission. So advantage of this hydraulic transmission, first is there is no need to apply clutch, and here we are using the clutch to disengage the engine shaft with the gearbox, but here we are completely eliminated the gearbox, so there is no need of clutch. Then control speed is possible in both direction. Third is speed can be set to any value. Fourth is single lever is used to control the speed and direction. We are using only a single lever, but in case of mechanical power transmission system, we need to use this lever, and we need to make gears which are 1, 2, 3, 4. Here it is completely eliminated. We are using only a single lever and not the various position of this lever. So next is it is having low maintenance. It is having high pressure oil, can be used for power steering. Again, we can say that less response time. Then power loss due to friction is minimum here in case of hydraulic transmission system, but in case of mechanical transmission system, power loss is more due to friction, because there we are using gears to transfer power from engine to wheels. But there are some disadvantages of this hydraulic transmission system. First disadvantage is it is more expensive, because it is having lower efficiency as compared to the mechanical transmission. And third one is it cannot be towed or may damage the pump. Meaning of what towed can be taken as it cannot be disassembled and reassemble easily. If once you disassemble this hydraulic transmission system, then it may damage the pump. But in case of mechanical system, a number of times you can disengage and engage the mechanical transmission system, and so on. So here we are going to see another concept of this chapter, which is power unit. So what is power unit? The power unit, it is the set of component which produces high pressure oil, and they can be assembled together, known as the power unit. It provides pressure energy for the operation of hydraulic system. It moves fluid throughout the system. It provides a safe maximum safety or pressure. Then it assisting in maintenance and correct system operating temperature and fluid cleanliness. A hydraulic system is basically made up of two sets. A set of components which produce motion, and a set of components which produces high pressure oil. Components which produce motion are cylinders and motors. They are internally part of They are integrated part of the machine, are fitted to moving parts of the machine and are unique for specified machine. But the components which produces high pressure oil are universal. Hence they are assembled together as a single unit and made available in the market with name hydraulic power pack. So what is hydraulic power pack? It is a device or set of device which is used to produce the high pressure oil, and we are naming it as a group, and we name this group as hydraulic power pack. Then what are the components of this hydraulic power pack? The components of hydraulic power pack are accumulator, then pump, then reservoir, then motor, and this manifold for multi-connection, power gauges. The single name for all these components assembled at a single place is given as hydraulic power pack. Then hydraulic power packs are readily available in the market. One can have it as per his choice. They have no need to purchase the components and to assemble them. Hydraulic power pack basically consists of oil reservoir, then hydraulic pump with electric motors, pressure relief valve, then delivery pressure gauge, manifolds with pipe connection. Manifolds means there are multiple connections are provided here in manifold. Apart from this, it may also consist of several other accessories such as accumulator, heat exchanger, and control valves. We are familiar with the accumulator, heat exchanger, and control valves. Also, I show you control valves such as 4x2 control valve, 3x2 control valve. I hope you remember all this. So here we are going to see next slide. So power unit, a basic power unit consists of a prime mover to give it to the system, the pump to pressurize the hydraulic oil, the reservoir to store the oil, then pressure relief valve to control the maximum steam pressure, then filters to clean the hydraulic oil, then plumbing to transport oil through system suction. I'm going to explain working of these components one by one in next slide. So this is the complete assembly of power unit or hydraulic power pack. So what is contains? You can see on your screen it contains heat exchanger, then filters, then pump, then prime movers. Dear Rohan, you can. Okay, so this is the combined diagram for power units having heat exchanger, filter, pump, prime movers, then manifold, reservoir. All these are the components of power units. So we are going to see the classification of this power units. First one is vertical power unit. Second is horizontal power unit. Third one is portable power unit. So here we are going to see the information about the reservoir. So what are its functions are listed here on screen. The function of fluid reservoir. So what is reservoir? It is a place where we are going to reserve the oil which we are going to use in the hydraulic system. So this oil is kept at a place and we name it as reservoir. So first function of this reservoir is to provide a chamber to store sufficient amount of hydraulic oil. Next is to cool oil coming from the return line, dissipate heat to surrounding. What is its meaning? Normally pump up the oil and increases its pressure. This high pressure oil is moved to the system And you know, as the pressure increases, its temperature also increases, because pressure is directly proportional to the temperature. So as the pressure of oil increases, its temperature also increases, and when this high temperature oil comes back in the reservoir, and it's sent directly again to the system without cooling, then the system will get heated, and if the system is get heated, then it will damage. So what is the function of reservoir? To cool this high temperature oil coming back from the system to the reservoir, so that the system remains cool. So for this purpose, it is required to dissipate heat of this oil to the surrounding. Dissipate means to pass the heat to the surrounding. Meaning of word dissipate is to transfer or to pass. Then to allow contaminants to settle down and remove them. When oil moves through the various pipelines or through the system, then it may come back along with some contamination or some foreign material. So when this oil return along with these contaminants, then it is desired that reservoir allowed to settle down. Settle down means to sit at the downside of this at the base of this reservoir, and it can be removed easily from the reservoir. Next, to accomplish the dissipation of heat by its proper design and to provide a radiating and convective surface to allow the fluid to push. Again, it is related to the dissipation of heat. The next is to allow air bubble to come up and vent them out. Normally what happen if the reservoir is completely packed, at that time in reservoir vacuum may be created in reservoir to allow to remove this or to eliminate this vacuum. What we are doing to produce a vent of air, so that air can comes inside and the vacuum cannot be created. So the function of reservoir can be stated as to allow air bubble to come up and vent them out. And sometimes if the oil come up with the air bubbles, then this air should be removed in reservoir. The next is to give support for mounting of pump and valves motor. Actually, reservoir it is the biggest part of our hydraulic power pack, and so it is desired that on this it should be provide the base to mount the pump and valve motor. Okay, we are going to see another topic on the. Okay, so this is the construction detail of reservoir. You can see here. Uh, The bottom portion is of reservoir, and on this reservoir we are mounting this pump along with the motor. So the function of pump is to provide a base to the pump and motor. So here we can again see this is the suction line, this is return line, all these are the components of reservoir, or you can say that this is the part of hydraulic power pack. The suction line is having filter at its starts, so to eliminate the foreign material entry without oil in the pump suction. Then this is the pump. It is continuously sending this high pressure oil to the hydraulic system, and this pump is run by the motor here. Okay, so this is the top lead, this is the suction line, and this is the return line. Both this suction line and return line should be deep inside the oil level. Otherwise, if the return line is remain up or at some height from the oil level, then there is a creation of foam may occur. Then there is a manhole is present here. Then this is a drain wall. Drain wall is used to remove the oil when we are going to do some maintenance or cleanliness of this reservoir. At that time, we are using the drain wall. So this is the another diagram of this reservoir. The components are same here, but just the diagram is different given in another book. So I am going to show you both the diagrams. So these are the features of hydraulic reservoir. what are the features of hydraulic reservoir are listed here. First one is tank, then filler, then breather, then side glass, and fifth one is the intake filter. All these are the components of reservoir. Then we are going to discuss the first component, which is tank. So tank contains sufficient quantity of oil. It is 3 to 4 time pump discharge. The tank, it is the place where we are going to store the oil. It should be contain sufficient oil so that the total quantity of tank is 3 to 4 times the pump discharge. The next one is filler. Filler, it is used to fill the new hydraulic oil into the reservoir. If you observe the reservoir, then there is a single outlet is provided where you are going to fill the new hydraulic oil, and this component is known as the filler. Then breather, it is the vent that filters air to entering and leaving the reservoir. As in previous slide we discussed about the air ventilation, air vent. So breather is used to avoid the creation of the vacuum in reservoir. Then fourth one is the side glass. The side glass is used to check the oil level in the tank. It showed the level of oil in the reservoir without having to open the reservoir. Side glass, it is just the provision of the transparent wall so that you can see the oil level inside the reservoir. Then fifth one, it is the intake filter. It is usually a coarse filter that is attached to the suction pipe. It does not allow contaminants to enter in suction line. Okay. So here we are, the baffle plates. The purpose of baffle plate is to separate the pump inlet line from the pump outlet line to prevent the same fluid from recirculation continuously within the tank. Suppose here, just see on this diagram of reservoir without baffle plate, here may be a probability of what this return oil coming through this return line, which is heated one, can be moved directly to the suction line, and this heated oil can remain circulating throughout the system, causes to heat the system. So to eliminate this heating of the system, we are going to place baffle plate here. We are going to place baffle plate here so that this oil coming from the return line should take maximum time or should travel maximum distance. During this travel of maximum distance and maximum time, it dissipate its heat to the surrounding or to the adjacent oil or to the adjacent air present in around the reservoir, and it becomes cool, and this cool oil can move, can suck through the suction line and circulate through the system so that the heating of system is achieved here. So the main purpose of baffle plate is to just separate the pump inlet from the return line to prevent the same fluid from recirculating continuous within the tank. Then to permit the foreign substance to settle down to the bottom. Here what happened, due to presence of this baffle plate, the speed of oil which is coming through the return line is get reduced here. Because of this reducing in the speed, this oil get stable here, and the heavy foreign particle containing in that oil may settle down at the bottom. The next is to allow entrance air to the to escape oil. We already discussed this topic. Then it is having suction and return line. Suction line is used to suck the oil from the reservoir and it is supplied to the pump. And where the return line, it is a connection where the oil from this system is comes back to the reservoir again. The return line is above the oil. The return oil can make a foam so or draw in some air. So this return line is always tipped inside the oil level. Then next is strainers and filter, and next is drain plug. Just read this slide on your screen. So here we are going to see the types of reservoir. It is having three types. First one is non-pressurized. So these reservoirs operates at atmospheric pressure and they are vented to atmosphere using an oil filter or separating diaphragm. So the in case of non-pressurized reservoir, the oil content in reservoir is non-pressurized. Means its pressure is atmospheric pressure, or you can say that high pressure oil or low pressure oil is not present here. The pressure inside the non-pressurized reservoir is equals to the atmospheric pressure. Okay. So next type is pressurized reservoir. These reservoirs are pressurized inside between 0.35 to 1.4 bar and has to be provided with some methods of pressurized pressure control. There may be a small air compressor to maintain set charge pressure, or it may pressurizing improve suction characteristics of pump by providing additional suction head. So to provide the additional suction head, we are going to use the pressurized reservoir. Then here are the facts which we are going to consider during the sizing of reservoir. All these facts are already discussed in the previous. There should be sufficient quantity of oil is present. It should deliver the or air ventilation. Air vent should be produced there. It should maintain the oil level high enough to prevent the whirlpool effect. And it should have large surface area to dissipate heat generation in the system. And it should have an adequate airspace to allow for the thermal expansion of oil. Okay. So here we are stopping, and the concept of accumulator we are again going to revise it in the next section. I am going to share this. I am going to share the attendance link in WhatsApp group. Just wait for 2 minutes there. And today's section I am going to end here. If you have any queries, then you can contact me on my personal WhatsApp number. Thank you.